Hello, my name is Kylee Kublin, and today I'm going to be sharing my lab report on the quarter 3 chemistry experiment between sodium chloride and silver nitrate that forms a chemical reaction. Well, what exactly is a chemical reaction? Well, according to Khan Academy, a chemical reaction is when chemical bonds between atoms are broken or formed. There must be a reactant and a product within a chemical reaction, and unlike physical reactions, it's often hard to physically see a change in the products. Formulas for chemical reactions are often set as AD plus CD equals AD plus BC, and that's just an example of a double replacement reaction. There's also synthesis, decomposition, single replacement, of course, double replacement, and combustion reactions, all which qualify as chemical reactions. These chemical reactions often involve the process of stoichiometry, which is used to solve for quantities or theoretical values. You can use processes such as the mole ratio, which is the ratio between moles in two compounds in the chemical reaction, to solve for missing quantities within stoichiometry. Additionally, within stoichiometry, and today, we'll be discussing this use of stoichiometry in order to find limiting and excess reactants. The limiting reactant is the chemical that runs out in the equation first, while the excess is left remaining. Both of these are vital within chemical reactions, and we will be exploring them today, and it helps show that chemical reactions are necessary for all things in our life to function and work. In my quarter 3 lab, I examined the chemical reaction between sodium chloride and silver nitrate, which forms silver chloride and sodium nitrate. The balanced chemical equation shows a 1 to 1 to 1 to 1 ratio, which essentially tells us that the mole ratio is all 1 to 1 when you compare two compounds to each other. That's why we have a 1 in front of these chemical compounds. The equation also has symbols like the AQ or this S, which reveals the state of matter in which each chemical compound is in. And while most of the compounds are aqueous, as seen by the AQ, there's a solid, which is silver chloride. And as I said before, this is an example of a double replacement reaction because there are two replaced elements in the product from the reactants. What is important about this chemical equation is that it allows the chemist to determine the relationship between sodium chloride and silver nitrate before physically creating it, and the chemist is able to determine the correct amount of grams needed or how many moles they're using in stoichiometry in this experiment. Now that we have explored the chemical equation behind this experiment, we can look at the physical procedure I had to follow in order to officially determine the relationship between sodium chloride and silver nitrate. In this lab, we used lab safety equipment, as silver nitrate would stain our skin black, and both chemicals are not truly safe to ingest or inhale. And then we also had to collect our beakers, Erlenmeyer flasks, and stirring rods before we could start. Now, once we are geared up, we had been given our amounts of chemicals that we had to weigh using a mass balance in grams. That amount of chemicals would be mixed with distilled water in order to dilute the solution, and slowly the silver nitrate would be mixed, and then the sodium chloride would be mixed into this silver nitrate, where a white solid would be formed from the two clear solutions. Once formed into this white opaque solution, I used a heating plate provided by my instructor and had to slowly mix the solid. Once it was completely formed, I had to filter it into this Erlenmeyer flask and filter paper. I had completed the filtration process early, so my filter paper air dried rather than being placed into the drying oven, which will be discussed later in my summary. Once the paper and solid had dried to what I could tell, I was able to weigh it and receive my final weights. Here is a data table of the substances and mass in grams of all my data. I first weighed the assigned amount of silver nitrate, which came out to 2.25 grams, and then I weighed the assigned amount of sodium chloride, which was 0.85 grams. Also, because I used the solid from two products within the filter paper, I had to weigh out my filter paper, and I got 1.66 grams. When I weighed the final solid, which also included the filter paper because it was contained within it, I got 3.65 grams, and by subtracting the weight of the filter paper, I got the experimental value of the solid to be 1.99 grams. And this color actually turned out to be an opaque mauve color from its original white color when we initially mixed the two chemicals. Okay. At the top here, I just have my balanced equation once again to show you what I will be talking about. This data can be used to find the limiting reactant and excess reactant that I discussed in the first slide. The sodium chlorate forms 0.015 moles of silver chloride, and it is the excess reactant because there is more sodium chloride than silver nitrate, and therefore will run out only when there is no more silver nitrate. The silver nitrate forms 0.0132 moles of silver chloride and can be determined to be the limiting reactant because it creates the smallest amount of moles of silver chloride and will run out before the sodium chloride. Now, to find the theoretical yield, you must take the limiting reactant and the amount of moles it forms for the precipitate, silver chloride, and use dimensional analysis in order to find the grams of silver chloride from this equation theoretically. I found that there is 1.89 grams of silver chloride from this experiment for the theoretical yield. Finally, I must find the percent yield, which you can find by dividing the actual yield by the theoretical yield, with the actual yield being the value of the solid we found and inserted into the data table, 1.99 grams of silver chloride divided by 1.89 grams of silver chloride. Then, once we multiplied that by 100% in order to find our percentage, I discovered that I received a 105% yield of silver chloride, creating a negative 5% error. This lab shows that silver nitrate and sodium chloride form the precipitate of silver chloride in the aqueous solution of sodium nitrate. As seen in my calculations, I have received a 105% yield of silver chloride, which is over a 100% yield of silver chloride, which shows that my results gave me a heavier solid than my theoretical weight. This can be due to the lack of precision in the mass balances I used to not only measure the chemicals but also measure the final solid weight. This can also affect the amount of chemical added, which could have increased the limiting reactant and caused a need for more of the excess reactant, which would also add on to the weight in order to satisfy the 1-to-1 mole ratio. Also, when filtering my solid, I had to use distilled water to wash the precipitate and remove any aqueous salt left, and any extra weight might have been due to me not properly washing off all the aqueous salt. And with me washing it, it could have not been fully dry, as which I shared that I did not dry it in the oven, but rather on the counter, as my instructor felt that the extra day of drying would be fine for it to remain out of the dryer. However, the extra 5% might be due to this water weight not being fully lost in the drying process. Now, this is something important to remember because that any extra product will ultimately cost more money in the real world. It is seen that 100 grams of silver nitrate cost $255, while 500 grams of sodium chloride costs $5.48, which aligns with our limiting reactant silver nitrate because silver nitrate will cost more per gram than sodium chloride. Now, when the product costs more, the chemist or whomever is making the product is going to want to limit the amount of the expensive reactant, as it's going to make the experiment more expensive if it is wasted. As for the excess reactant of sodium chloride, it will be measured to match the amount of silver nitrate because its smaller cost allows for more waste without an extremely expensive experimental result. Therefore, it can be concluded that the limiting reactant of silver nitrate and excess reactant of sodium chloride creates a white, opaque solid of silver chloride initially, ultimately turning into an opaque mauve color, and this aqueous solution of sodium nitrate shows a chemical reaction. And because chemical reactions are found throughout our daily lives, in addition to my lab report, I have decided to discover the real world application of baked goods within our lives and how they're important to our everyday lives. Okay, now before we begin with all the wonderful uses of baked goods, we must understand what a baked good is. A baked good is defined as a batter or dough that is baked. Pretty simple, according to Merriam-Webster Dictionary. This can include breads, cake, cookies, crackers, some cereal products, and most pastries. Baked goods can be found in places such as bakeries, homes, schools, and many more, which make them pretty vital for us. Now, what makes these goods rise? Why is cocoa powder able to make it taste like chocolate? Why does food coloring dye the batter or frosting? In flour alone, there's the process of protein bonding, where proteins in the flour mix to create gluten. Baking allows the gluten chains to grow and expand. There's caramelization, which is the reaction where sugar is heated, causing water to be released, and molecules like diacylate and furan to be produced the longer it is heated. However, today, we will be focusing on the chemical reaction of leavening, where carbon dioxide is released in order for the good to rise and be light and fluffy. More specifically, we're going to be looking at the chemical reaction between sodium bicarbonate and citric acid, better known as the reaction between baking soda and citrus fruits, which should cause baked goods to rise or become the reaction of leavening. In a baked good, baking soda would be added along with flour, sugar, sometimes salt, to lemon juice, butter, vanilla, milk, eggs, or any other ingredients necessary for the recipe. But what's important is that during the heating time, the baking soda or sodium bicarbonate and lemon juice or citric acid combined with their product, causing the rising of the baked good. The rising from the sodium bicarbonate and citric acid forms carbon dioxide, water, and trisodium citrate. The CO2 is released in a gas, but it can also be seen in the little bubbles spread throughout baked goods and is the reason why baked goods rise. H2O and trisodium citrate remain in the good as they keep the original structure from returning to its original state. There's a 1 to 3 to 1 to 3 to 3 ratio, which is the same as the mole ratio, in order to balance this reaction with the law of conservation mass, which states that chemical reactions of mass can neither be created or destroyed in a reaction, which I found according to National Geographic. This reaction is also known as a double replacement reaction, specifically an acid and base forming a salt and water. Acid-base reactions always form a reaction, which is why this combination of sodium bicarbonate and citric acid is guaranteed to work. Now, these images show how sodium bicarbonate and citric acid work to cause the bread products to rise and expand and allow them to be light and fluffy, which allows them to ultimately taste better. And we can see this bread rising with the cracks and these cookies going from a tiny little ball to expanded. Okay. And I just have a video of a cookie recipe, and I'll pause it when I want to add.
Today is cookie day, one of our favorite days of the week, and I'm making the lemon sugar cookie, and it couldn't be simpler. I have 3 cups of all-purpose flour. To that, I'm adding a teaspoon of baking soda and a 1/4 teaspoon of fine salt. If you're using your coarse salt, just make sure that you use 1/2 teaspoon instead. Whisk everything together. People often under whisk, and I experienced under whisking in a carrot cake that I made, and all my carrots turned green because my baking soda wasn't properly incorporated. It was really insane.
So I just wanted to add on to the point she made about the baking soda needing to be equally distributed in order for the rising to occur. If it's all bunched up, it's not going to be able to properly mix with the citric acid. So in cooking or baking, you need to mix it into the ingredient in order for it to be properly expanded.
Whisk properly. Set that aside for a sec. Then you need a tablespoon of grated lemon zest. Make sure to really well scrub your lemons, and if you can find pesticide-free lemons, even better. Add your tablespoon of lemon zest to 1 3/4 cups of granulated sugar in a mixer. And then to that, add a 1/4 cup of light brown sugar. Beat those together for like 1 or 2 minutes. When you can really strongly smell your lemon, add 2 sticks of unsalted butter, room temp. Beat until light. Once your sugar and butter are well combined and fluffy, you can add 2 eggs, one at a time. And then a tablespoon of lemon juice. And then add your flour mixture. Be sure that you're careful when you turn your mixer back on because, well, you know as well as I do what happens. Flour.
So she mentioned how she's adding 1 tablespoon of lemon juice into the 1 teaspoon of baking soda, which actually is roughly a 1-to-3 ratio of sodium bicarbonate to citric acid, which is equal to our balanced equation, which has 1 mole of sodium bicarbonate to 3 moles of citric acid.
Flour everywhere. Careful, careful. Yeah. Done. I have some parchment lined.
Also, the reason why she mixed the ingredients is once again, you want to equally distribute it so all the sodium bicarbonate molecules and all the citric acid molecules combine together.
Baking sheets here. This is a 2-inch scoop, so these are going to be kind of big cookies. Scoop the cookies. You want to leave about 2 inches between each cookie so there's plenty of room to spread.
And also, the reason why these cookies aren't automatically spreading is because there's been no heat added. So, while there is no heat and these molecules are together, only the heat of the oven will allow it to rise and expand and release the CO2, like I said before.
You'll want to flatten the cookies a little bit. I'm just using my hands. And then for a really unique and special topping, sprinkle the tops of your cookies with coarse sanding sugar. Then you go in and you brush that with a little bit of water. This helps it to adhere and create the first layer of sugariness. And then you go back in and sprinkle with another layer of sugar, and it's gonna be amazing. It's the crackliest, sparkliest cookie you've ever seen. Have your oven preheating to 350 degrees, and these cookies will need to bake for about 15 minutes. You'll probably want to rotate the pan once while they're baking. When they're done, they're crackly on top.
Okay. So now that the cookies are done baking, we can see they clearly rised and got fluffy and spread after baking, which is our example of leavening. And also the sugar she added on top, that's an example of the caramelization reaction that I discussed before.
Today is cookie day, one of our favorite.
Okay. So, why is the reaction of sodium bicarbonate and citric acid important to baked goods? As this reaction is known as the leavening reaction, where CO2 is released to create light and fluffy goods, there would be no longer be any form of rising through the use of baking soda within a baked good. So, cakes, cookies, muffins, etc., would be flat and quite unappealing to eat. Without this rising too, it allows for the good to taste better, which is one of the more important reasons for this reaction to take place. And according to Science Direct, leavening reactions can also help with a uniform cell structure and help reduce the density of goods, which overall make the good taste better and makes people want to eat it more. So, overall, the use of sodium bicarbonate and citric acid is vital for our world as it allows for goods to rise with the release of CO2 gas and for products to have the iconic, fluffy, and light texture that is so lovable. Without the application of baked goods, our world would never be the same, and it shows why chemical reactions are so important to our lives, even if we don't notice them. And here is my works cited. Thank you so much for watching my presentation, and have a wonderful day.